Okay, one of the big advantages to using components is that we can add vectors together using components, and then take those components and add them back together at the end to get brand new vectors. So it gives us a different way to add vectors rather than just drawing them out head to tail every time. So we're back to our grid. Again, remember each side is worth 10 kilometers. And we went before what the different components of each one were. So what we're going to do is we're going to take vector A, we're going to add it to vector B, and we're going to add it to vector C. The way we're going to do that is to add their horizontal components and then their vertical components. So let's start with east-west. We have 20 kilometers to the east for A. Then we're going to come back 20 to the west. Now 20 east and 20 west cancels out to 0. And then we have left over 10. So 10 kilometers at 0 degrees. North-south, we're up 20. Then we're down 30. So now we're down 10 overall. And then we're down 20 more for C. So we're down overall 30. That's at 270 degrees. Now, if we want to determine our actual overall displacement, we're going to want to take 10 squared plus 30 squared, and that's the displacement's magnitude squared, so then second function square root of the answer, and we get 31.6. kilometers. So we just added A to B to C, and we got this overall result. Now we only got the magnitude. We'd have to look a little more detailed to get the direction, but at least it allows us a quick calculation of how much the magnitude is. If we had D, E, and F, again, east-west, we've got 20 to the east, 30 to the west. So overall, we're 10 to the west, and then 10 more to the west. So 20 kilometers at 180 degrees. North-south, we're looking at down, or south 20 more. So now we're 40 south. And then 20 more, so we're 60 kilometers at 270. Now again, we're going to take 20 kilometers this way, and we're going to take 60 kilometers this way. They're at right angles to each other automatically because we did east-west and north-south. That's going to allow us to get the resultant, which is the straight line from where we started to where we finished, which is the hypotenuse of this right triangle. So we can bring back, we want 20 squared plus 60 squared, and then take the square root of the answer, or the square root of 4,000, and we get 63.2. 63 to 2 significant figures is probably what I should round it off to, kilometers. Again, that's only the magnitude. That doesn't tell us the direction, although we could go back to SOHCAHTOA and we could do some calculations to determine the direction. We'll save that for later. Okay, pause the video and try G, H, and I, and A, J, and G, the last two there, and then check your answers against mine. Okay, so overall G, H, and I, we're looking at 40 to the east and 40 to the south. 40 squared plus 40 squared. Take the square root, we're around 57, 56.6. A, J, and G were 20 at 0, 20 kilometers to the east, and 10 kilometers to the north. So 20 squared plus 10 squared, take the square root, and we're looking at about 22. Now, something else to keep in mind, that these are all hypotenuses of the hypotenuse of a right triangle. That means they need to be larger than either of the two components. So 31.6 is larger than 30, 63 is larger than 60, 57 is larger than 40, 22 is larger than 20. So you can always check yourself with that. they always have to, the hypotenuse always has to be the largest side in a right triangle. Okay, so there's some of the ways we can use components to add vectors together and break vectors down. Often we break them down into components and then add those components together, and then we bring them back together at the end so that we can figure out the total amount of vector addition. And it is vector addition, so your answer should have a magnitude, should also have a direction if you're looking for the total vector, and it will not be as simple as 1 plus 2 equals 3. You could have 2 plus 2 equals 2 in a vector addition. You can have just about anything happen in vectors based on the direction, because the direction makes a difference. That's it for guide sheet number 3.